I'm Nicole Fiorellino. I'm the Extension Agronomist for University of Maryland. If you've seen me talk at one of the agronomy meetings so far this season, you're in luck. Slightly different talk today. Jenny's probably the only person that can see me give a talk and say, I want a different one at my meeting, and I just come up with a different talk for her. So anyone who's seen me give the other talk and you were bored with it because you've already seen it, a little different today because Jenny asked. So thank Jenny for spicing it up a little bit. Similar topic. We're still going to talk about biologicals. We're going to do a little bit of a review because we have to make sure everyone gets their credits. We're going to kind of talk a little bit broadly about nitrogen and phosphorus, but then I'm going to zoom in and present some results from a national protocol, a national evaluation, a national team that I'm part of, and show some of the results kind of broadly and then zoom in and focus on what we saw here in Maryland as well. And don't worry, I'm going to cover CEC like you asked me to, Jenny, for credit. It's in there. I just took it out of the title. All right? So let's start off kind of broadly talking about these biological input products. All right? This is a term that I've coined because I need a way to categorize them. So I'm calling biological input products anything that's a product that adds some kind of living organism to your soil or broadly kind of to your growing ecosystem, okay? This is a market area that you all have seen. I know everyone's heard about them because I get about a bajillion questions about these products, all right? So I know everyone is being kind of targeted and it's marketing towards you, all right? This is definitely a growing market. I kind of think of these, and if you've seen my other presentation at one of the other agronomy meetings talking about hacking agronomy, right? Some of these products, I kind of think of them as like trying to hack agronomy, and not with a negative connotation, but trying to find some kind of a shortcut or maybe a short circuit part of either the nitrogen cycle, phosphorus cycle, or just kind of broadly what we know about growing crops, plant growth, all right? And so some of the marketing or some of the claims that we see with these products are, we're helping the plant be more resilient to disease or stress, or, we're generally making that plant more healthy and increasing growth, and yeah, okay, we're hoping that we increase yield. And so, at the end of the day, I think that's what we care about, that's what we get paid on, and so that's what we have to be conscious of, that we're actually seeing a benefit in that area from these products, all right? Everyone wants to know, do these products work? That is the question I get all the time. Do they work? And I give my classic extension answer, which is, it depends, right? So yeah, it depends, right? And if you ever thought we said it depends, in the past when we talk about, adding nitrogen fertilizer, it really depends. When you get in this biological realm, you're adding microbes to a system that there's already microbes, so it extra depends if these things work, all right? A concern that I have, or just, what I'm seeing as this biological market is expanding, is that oftentimes there's little or no third-party evidence, okay? And whatever, do you, companies, you do whatever you want to do. But, I think that is an important component, and I think that is something that, you guys as growers want to see or should want to see, that there's some type of third-party evaluation, all right? My general thoughts on the answer to the question, do they work, is I really think that's that's a personal decision. And something to consider is the return of investment of using that product versus just changing your management and being better at your management, right? And again, this is a personal decision. This is going to look different on everybody's individual operation. But if, for example, you're being sold a product that has to be put out in season to provide nitrogen, why don't you just put the nitrogen out then, right? So again, these are just questions. You have to ask yourself these questions, and you have to think about these questions for your own operation. I can't tell you if it's going to work or not. I'm just trying to bubble some stuff up to the surface for you to think about to make that decision, okay? All right, but first, let's go back to some of the basics here. I want to step back, and we'll talk a little bit about nitrogen, talk a little bit about phosphorus and soils, and then we'll jump ahead and we'll show some of the results, all right? So, how do we feed nutrients to our plants? I hadn't been putting this slide in my previous talks, partially because I didn't have enough time, but also because I assume that we all know this, and we all do, but sometimes it's good to have a little refresher. And I'm often reminded when I get asked to give talks to like master gardeners, for example, or beginning farmers, that these folks just truly don't understand how to grow plants. That's why they've showed up for these classes, right? They're beginning farmer, they want to learn how to farm. So I really appreciate the reminder to kind of step back and go, what is some of the knowledge that we take for granted, that we just understand, that other people don't? And sometimes it's good to have a little bit of a refresher, all right? So you all have seen me show you the nitrogen and phosphorus cycle plenty of times, all right? So how do we feed nutrients to our plant? When we visually look at these cycles, a common theme between the two of them are these boxes that say plant uptake, right? Plant uptake of these nutrients, and it's pointing to the roots of those plants, right? Any version of the nitrogen and phosphorus cycle, any version that I Google, that I find, that's what we see. That is the route that our plants are meant to take up nutrients, all right, through their roots, all right? We, again, I know, very basic, but sometimes we got to step back and think about it, all right? So we apply the nutrients that we want our plant to take up. We apply it to the soil, all right? We expect that our soils have some capacity, have some ability to hold on to those nutrients, but not too tight and not for too long, because we want that soil to be able to make those nutrients available to our plant so it can take it up in its preferred method, all right? This is like, at the crux, what we do. And so all we're trying to do is really kind of hack and really try to figure out how we can optimize that system, all right? Again, in doing some of these beginner farmer trainings, I think a lot about the words that we use when we're talking about how nutrients behave in the soil, right? And you've probably heard me say in the past, nutrients are adsorbed to our soil surfaces, right? Not absorbed like your muscles, right? This diagram shows when we think about absorption, it's like we eat our food and we absorb those nutrients. But we're talking about nutrients in soil are actually adsorbed, all right? So the blue circle here represents a soil particle, and these yellow circles are representing, one of our nutrients, one of our positively charged nutrients. And there's just a relationship there at the surface. If you want to get technical, these nutrients are actually kind of swarming around. Like if you can think back to chemistry and electrons kind of swarming around a nucleus, right? That's really what happens, all right? There's a charge here, there's some kind of attraction, and those nutrients are adsorbed to our soil surface. I'm saying that very clearly because sometimes I talk really fast because I'm from New Jersey, and maybe you don't hear exactly the words that I'm saying. So we're saying adsorbed to that soil surface, all right? And, talking about soils, my favorite topic, pretty much, I'm assuming everybody knows, our soil texture is the proportion of sand, silt, and clay particles. And those clay particles, the really teeny tiny particles, that's where the magic happens. That's where this adsorption is taking place, on those clay particles in your soil surface, all right? This is an electron microscope photo of a clay particle. These things are so tiny, we can't even see them with a regular microscope, all right? So it's all about the surface area here. You see how this looks like a stack of papers almost? Like a bunch of little layers, like a biscuit. Oh, I'm getting hungry for lunch. I'm thinking about food analogies now, right? Like a biscuit with all those flaky layers on there, all right? That's all surface area. And that's where we see those negative charges, all right? Our clay particles are all made up of negative charges. And this is simple, just like magnets, right? Our nutrients are positively charged, and they're attracted to the negative charge on that soil surface. That's how we get that adsorption, all right? Just magnetic charges, all right? Again, this is basic information that we all know, but we're thinking about how we can hack, how we can optimize our systems here, all right? So at the crux of what we are doing is we are putting our nutrients in our soil. They're swarming around our clay particles, and then we're hoping they will get released and made available to our plant during the season while it is growing. All right, so our clay particles have negative charges that attract positive charges, all right? Positively charged are called cations. That's this list over here. I'm not going to read them, and you don't have to memorize them. You know that these are really important, all right? We also have our anions, though. These are negatively charged. What happens if you put two negatively charged magnets together? They repel, right? So we have to think about our positively charged cations, but we also have to be thinking about our negatively charged anions as well, all right? And you see your nitrogen exists in both of those charged forms, all right? We're going to get back to that later, I promise. Okay, so how do we feed nutrients to our plants? How do we move forward with this refresher that we've had on our basic soils, right? We have a general understanding, I'd say all of us, and we're going to lump us all together, of nutrient dynamics in our systems, all right? And we are constantly aiming to optimize that, right? How do we tweak? How do we make better management? How do we make better decisions so we can really tweak that, all right? I keep saying that word because I can't think of a better word right now, all right? We know, and you guys who have seen me show this phosphorus cycle slide for like the past decade, because I haven't found a better one yet, all right? We know that not only do we have plant available forms of our nutrients, all right, we also have other forms of our nutrients that exist in the soil that are not available to our plant, all right? We talk about it a lot with phosphorus because there's a lot of different forms of phosphorus in the soil, but our plant can't get to them, right? But we also have organic phosphorus and organic nitrogen. That's another form of nitrogen in our soil, but our plants cannot immediately take them up, all right? So again, we're looking to try to optimize our systems here. Optimize our systems, will I say, without adding more nutrients, right? Because we live in the land of nutrient management. We can't go above our recommendations. So if we can't add more nutrients to the soil, how do we mine from the soil what's already there? And for nitrogen and phosphorus, the similarity there could be that organic form, but it's not directly available to the plant, all right? So we're going to go into this a little bit more in depth here, but this is kind of the premise behind and the thought behind these biological products, all right? Can we upregulate, can we increase the activity of the microbes that facilitate this process, right, of making the organic nutrient available to the plant? Is there a way that we can hack this step right here and make those nutrients available to our crop even when we've already added fertilizer to the system, all right? That's kind of the general premise behind any of these biologicals, I will say, all right? So, setting the stage there. We're all on the same page, all right? So, I'm going to go through and I'm going to talk broadly a little bit about what I'm calling modes of action for some of these different products. If you already saw me give this talk, I'm not going to name the products by name. I'm just going to kind of overall give a snapshot of, from my understanding, you know, what we're seeing is the mode of action of these individual products so we can think through the nitrogen cycle here a little bit better. All right? So broadly, when we're talking about different biological input products, I'm lumping them together. I'm lumping them separately as nitrogen and phosphorus products. Why? You all have heard me say this like ad nauseum, right? Nitrogen and phosphorus behave differently in the soil. We often lump them together when we're talking about management, but we really need to be thinking about them separately in terms of management because they behave differently, all right? So let's start with nitrogen. Generally speaking, these biological input products all function in one of two ways, okay? Their goal is to either amplify or increase the activity of some part, one of those arrows on the nitrogen cycle, okay? Or the other mode of action would be to try to minimize one of those loss pathways. So one of the like tons of ways that we know we lose nitrogen from our systems, all right? So those are the two modes of actions, either increasing some part of the nitrogen cycle or decreasing and loss from our systems. Like they can all be categorized generally that way, all right? So again, I'm not gonna name them by name, but let's zoom in and kind of go through what we're talking about here. So I showed you on the other image. I'm shopping around for a good image of the nitrogen cycle. I haven't really found one yet that I like, so I'm just trying a bunch out, all right? Same cycle that we just looked at. we've got our two forms of nitrogen here that are available to the plant, right? These are the only two blue rectangles that have arrows pointing to plant uptake, okay? Gotta switch hands here. And then we've got our organic nitrogen form that I talked about, right? But you'll notice there is not an arrow going from this organic nitrogen, this blue rectangle, to the plant uptake, because plants cannot take up organic nitrogen directly. It has to be transformed. It has to change form so that it can be made plant available. And we call that process, we call that transformation, mineralization, okay? This step has to happen in order for that nitrogen to be made available to the plant. I don't remember I'm going to start clicking to see good. Thought I set myself up there on these slides. All right. So this process of mineralization is an energy-intensive step, right? The system has to pay money, has to pay currency for this step to happen. All right, it takes energy to keep those microbes going and happy and to basically eat up and poop out that organic nitrogen so our plants can take it up. This is an energy-intensive process. And our systems are not going to waste energy and not going to waste currency for no reason at all. All right, so if it's necessary, if we need to make some of that organic nitrogen available for the plant, the system will expend the energy. But it's not going to just do it all willy-nilly if we've got plenty of plant available nitrogen available in that system, all right? So what does that mean? What I just described is when we say microbial activity is inversely related to fertilizer or plant available nitrogen in the soil. As we increase the concentration of basically free nitrogen in the soil, those microbes are like, nah, not wasting the energy, and they're going to slow down their activity, and we're not going to mineralize that organic N, all right? We're going to use what's available first. The plant's going to use what's plant available first, all right? However, here's what the products claim. This is their mode of action, all right? While you're increasing fertilizer or the concentration of plant available nitrogen in the soil, if you apply one of these biological products, it will short circuit that. This is the hack, right? It's going to kind of cancel that signal to the microbes to stand down. And they're just going to keep chugging away at mineralizing that organic nitrogen. This is the crux behind the scene of like what these products claim they're doing, all right? So you're getting your plant available N plus the organic N that's being mineralized. So that's the claim of what these products are doing. Hacking or short-circuiting the mineralization step of the nitrogen cycle. All right, so we do not want to rely on our soil to store an entire season's worth of N. You all have been hearing me up here for like at least 5 or 6 years telling you that, right? Split apply your nitrogen. You don't want to put everything out up front because our soils do not have the capacity to hold onto that nitrogen, all right? Organic nitrogen is the best option if you absolutely had to, all right? But we do not want to rely on the soil to store an entire season's worth of nitrogen. 5 minutes ago, we just showed those CEC slides, right? Why is that? Because only one of those plant available forms of nitrogen, that ammonium, that's the only form that's positively charged that we've got even a glimmer of hope of being absorbed to our soil, right? And a very slim chance that our soil is going to be able to hold on to that ammonium, all right? But the nitrogen in our soil that exists as nitrate, which is negatively charged, she gone, all right? If there's any bit of rain, that nitrate is gone, all right? Because our soils just have no ability to hold, those charges are just going to get repelled, all right? So we've all heard ad nauseum about the 4 Rs, and don't take that as negative. The 4 Rs are great and fantastic, and these are very clear and concise guiding principles when we're thinking about nitrogen management. But again, nitrogen and phosphorus separately, we got to carve out different pieces of the 4 Rs to focus on, all right? So when we're thinking about effective nitrogen management, timing is where it's at, all right? We want to ensure that we are applying that nitrogen to the crop just ahead of where we anticipate it's going to need it, all right? And not rely on that soil to hold on to that nitrogen for us because it's not going to be there when our plant needs it, all right? That's nitrogen. I think phosphorus is next. Okay, yes, phosphorus. All right, so biological input products that are targeted towards phosphorus, all right? Generally, these products are also similarly trying to hack some component of the phosphorus cycle. They're generally trying to prevent that adsorption, that attraction of the phosphorus molecule to the soil, by physically blocking it almost a little bit, right? Or trying to reverse that relationship, that attraction, that adsorption that's already happened, all right? But we know, we're gonna get into it, we all know phosphorus is different, right? We all know how our soil feels about phosphorus. It loves its phosphorus, all right? What I think is interesting or different or just something to think about with the phosphorus products is that some of these products that I'm coming across are actually additives. So you have to add them onto fertilizer that you're applying. One, that's a problem if you can't apply any phosphorus fertilizer, right? If you're in the boat where you're restricted from doing it, okay? And two, that goes back to thinking about that return on investment. Is it really worth it to add a product on top of a product? Again, I don't have the answer to it, but you need to think about that on your operation, okay? All right, phosphorus cycle. You all have seen me give this talk or give this slide and talk about this before. I know you have, all right? We're gonna dig a little deeper. We're gonna go phosphorus cycle 1.2 now. We're gonna dig a little deeper, all right? So you all have heard me talk about the blue circles that are the different forms of phosphorus that exist in the soil. And we know that our solution phosphorus, that's the only one with the arrow that's pointing towards the plant for plant uptake. And you've probably heard me say in the past that, these other forms of phosphorus are kind of held with a different degree of tightness, if you will, all right, or affinity, you could call it. And we just did our little refresher on CEC, and you're like, well, Nicole, you just showed me that phosphate had a negative charge, and you told me that negative charges get repelled in the soil. So we're gonna dig a little deeper into that, all right? So what I want you to look at here, and I know they're a little bit blurry, are the words that kind of describe this process, this transformation back and forth here. So when we're talking about adsorption and desorption, that's what I showed you with the blue and the yellow circles, right? There's a relationship, there's like a bit of a swarm with the charges, all right? Why does our soil have such a huge affinity for phosphorus? Why is it so hard for us to pull that phosphorus off of our soil and get into the plant, all right? That's because of this idea down here of these secondary compounds, all right? So bear with me. I know it's before lunch, and I'm going to get a little chemistry here, but just bear with me. We'll move past it fast, okay? I have been searching for a very long time for an image to help me really describe this to everyone, all right? So what I wanted to do here is kind of set the stage for what we're looking at, all right? This red, rectangle over here, this represents the physical surface of one of those really super tiny clay particles that I showed you, all right? And when we think about phosphorus, it actually exists as a phosphate molecule. So you've got your P in the middle, and it's surrounded by 4 of those oxygens, and it has a negative charge, all right? So we have some amount of phosphate that is in this adsorption phase. It's just kind of hanging around and swarming. Yeah, even though it's the opposite charge, it hangs out in there, all right? It hangs out. But where that strength really comes from, when we say that our plant roots have to rip the phosphorus off of the soil surface, it is because of the attraction here. These oxygens that are part of this phosphate molecule actually physically become part of the surface of the soil. I don't know how to explain that other than what I just said, right? The ions kind of move around, and those oxygens that are attached to the phosphorus also become attached to the surface of the soil particle. So they're no longer just like floating around out here, positive and negative charges. It's actually physically a part of the soil, and that's why I very dramatically say we have to rip that phosphorus off of the soil, because it's physically becoming a part of that soil particle. So think about that next time when you're thinking about your phosphorus, and you gotta rip it off of the soil particle because it's actually becoming part of the surface. We learned about this when I took soil chemistry. We had a professor and he drew everything on the board in chalk. He never had a PowerPoint slide. He drew every single one of these molecules with chalk on a board, and I could never recreate his drawings so well. And so I finally started finding some of these on the internet here. So I just wanted to share with you my excitement that a PowerPoint slide of this actually existed somewhere. So anyway, I wanted to give you guys that concept of that strength when we're talking about phosphorus. The exact opposite of what we're talking about with nitrogen, right? This is why I constantly stand up here and say we have to think about nitrogen and phosphorus differently. They behave totally differently in our soil systems, all right? I'm not going to go through all of these different pathways. I just wanted to show you a snapshot of like the figure from the soils textbook that we go through looking at how our plants take up phosphorus, all right? Plant roots have become really good at changing the conditions right around the proximity of that plant root to be able to dissolve, right, to rip that phosphorus off of that soil particle, all right? And a lot of it is mediated through pH. You all have heard me stand up here and talk about that before, right? Soil pH is extremely important for making that phosphorus available to the crop. And our plant roots are smart, and they do the same thing. They change the pH right just around the area of that root to be able to dissolve and rip that phosphorus off, all right? Our plants have evolved to get the phosphorus that they need, all right? And the important part to note, I'm not going to go through all 6 of these, but that really our plant roots have kind of figured out multiple ways to try to get that phosphorus. If one way doesn't work, they try something else, all right? But let's go back to those 4 R's, all right? If we're talking about effective phosphorus management, all right, what we need to be focusing on and what we're thinking about there is our placement, all right? That plant available phosphorus, the stuff that's swarming around out there, it's not going to move long distances in our soil like our nitrogen, right? I just said, you have nitrate in your soil and it rains, she gone, all right? Not with your phosphorus. So when we think about our plant roots being able to take up phosphorus, this is a really good image to keep in your mind. That plant root literally needs to bump into that phosphorus. It really needs to be in close proximity with it, really be able to touch it to rip it off, all right? So when we're thinking about effective phosphorus management, that's where we're thinking about placement. Nitrogen and phosphorus, not the same. All right, finally getting into the point of what Jenny wanted me to talk about. All right, so let's talk a little bit about biological seed treatment. So I'm going to talk to you in a minute about how I got involved with this group. These are just a couple slides to kind of set the stage for what we did, all right? So generally, the bioseed treatment market, I'm just kind of zooming in on the products that we specifically evaluated. Some of the claims are to improve nitrogen fixation, and I've listed the specific strains or the specific name of the microbes that carry out that action, right? So improve nitrogen fixation, better able to assimilate P from both organic and inorganic sources, increase nutrient use efficiency and uptake, stimulate growth of roots, and expand root absorption. And I'm not saying this like it's not bad. These are all good things. It's just making sure that they translate into that yield, right? Control diseases and nematodes. Again, awesome stuff that we need to be paying attention to, all right? So, in 2022, the Science for Success team, I'm going to introduce you to the Science for Success team in a second. They surveyed farmer members of state-level soybean boards. So I don't think Maryland or Delaware, honestly, was on that list. But they surveyed members of the state soybean boards to take a list that was like 30 products long of biological seed treatments and narrow it down to like 9 or 10, right? What were the ones that kind of kept popping up as most important that this group should focus on testing, right? And very specifically, the goal was to determine a yield benefit of these products on soybeans in locations across the country. So wide but shallow. We were trying to get as much geographical diversity as we could, all right? But we're not zooming in and taking a whole bunch of soil samples and plant samples and looking at roots and yada, yada, yada. We're measuring soybean yield. So that's why I said wide geographical diversity, but shallow in the sense we were only measuring yield, all right? So this is the Science for Success team. We are made up of the MEs, the extension agronomists, who focus on soybean. Shocker, in other states, they have multiple agronomists, and they all get to just focus on one crop instead of one agronomist that focuses on every crop. So most of these people only deal with soybeans in their respective states. But these are the extension agronomists like me, and we're all across the country. We had a planning meeting last August in North Carolina. This is us all sweating our butts off, standing in this field. Everyone's going, just take the picture already. We're really hot. Get us back on the bus. But no, it's a really great team. And for those of you who don't know, so I didn't know this, so I'm going to spend a minute to kind of share this. So for those of you who don't know, I'm sure most of you are aware that in Maryland we have the Maryland Grain Producers Utilization Board, and then we have the Maryland Soybean Board. And maybe you're like me, that at one point I'm like, can't we all just be on the same board? Does there really have to be separate boards? But there is a parent organization to Maryland Soybean Board called the United Soybean Board, all right? And they collect the checkoff funds that come from soybeans and distribute them down to the individual state levels, all right? So there's a United Soybean Board, there's actually regional soybean boards, and then most states have their own soybean board. That does not exist the same for corn or wheat or other small grains. There's not a united corn board, for example. So all the states kind of do what they want. So good in some ways, it gives the states flexibility to do what they want, but the really nice thing about this team is that we are all kind of individually funded by our own state soybean boards, but we have access to this United Soybean Board funding to do things like this. Come together physically in person at meetings and strategize about national research protocols that we can all execute exactly the same across the whole country, and we can pool that data together. So there's benefits to some of the rigidity that maybe comes with the United Soybean Board organization, because we have access to funding like this to bring us all together. Really, it just paid for us all to get together and talk for 3 days, our favorite thing to do. So I joined onto this group in late 2022, so I missed the window for getting on board with this proposal in 2022. So I'm going to show you some other data that's not from Maryland in 2022. All right? So, Science for Success. Yep, soybean specialists across the United States. We collaborate on research and educational efforts to bring soybean best management practice to soybean producers nationwide. We got to be specific about soybean because that's where the money comes from. All right? So, the team grew exponentially between like 22 and 23. We're now up to 29 members in 2023, and we have, I think, 4 different protocols that were executed nationally in 2023. Team received funding support from United Soybean Board. Yep, and then typically our state soybean boards will match or will kind of encourage the participation, and they'll share funds with that as well. All right. So, the focus here, biological seed treatments on soybeans. That's it. Very limited scope. So, in 2022, they had 17 states that participated with 51 total locations. So, in 2022, the first year, they didn't have a whole lot of different states, so I think Wisconsin had like 10. Wisconsin alone had 10 locations of the study, all right? By the time we got to 2023 and there were more people that were involved, we were a little bit limited. So I was maxed out. I could only have 2 locations in Maryland, all right? Everyone did this in small plots. We had 10 treatments, 6 reps. Like, we were basically told what to do. This was a national protocol. We came up with it together, and everybody executed the same thing. Randomized complete block design, 6 to 8 replicates. The products, here's the list of the products. The point I wanted to make and why we were a little bit limited in our locations, even in 2023, was that the companies actually donated the project to this, or donated the product to this group, right? So Ohio is actually who coordinated it. So the student there in Ohio collected all these products and shipped them out to us. So we were a little bit limited on the actual quantity of the products, hence why I only got 2 locations in 2023. They didn't have the brand names here from 2022. I will point out that from 2022 to 2023, some of the products were the same, some got swapped in with new products. So don't hold tight that, product number 1 in 2022 was the same as product number 1 in 2023, all right? We kind of got what we got and went from there. But you can see that there's a smattering of, different products here with different microbes, different organisms, and, I think there was something special about 5 and 6. They only got tested at some locations. But you can generally see there's kind of a smattering here of these different species. That was the word I was looking for. So in 2022, across the 17 states and the 51 locations, every single graph from every single location looked exactly like this, all right? So 1 through 9 were, go back to this, 1 through 9 were actual treatments, and 10 was an untreated control. Forgot to mention, everybody picked their own brand and maturity group of soybean in their state, right? So we weren't all forced to use a soybean that wasn't adapted for your region. So they sent you the product, and you put it on the bean of your choice, what you think is going to grow well in your state. Because obviously, with the geographic diversity here, we couldn't have all planted the exact same soybean, all right? So no one was setting this up for failure by planting a group 2 bean in Alabama. Just wanted to put that out there, all right? So I didn't participate in 2022, as I mentioned, but I plucked the graphs from Virginia, because that was the closest state to us that did participate in 2022. And as I mentioned, every single graph, I looked at every graph across all 51 of the locations in 2022. They all looked like this. So these box and whisker plots, you have our treatment along the bottom, and then you got your soybean yield on the y-axis. So yeah, from one location to another location, maybe the average yield was different, but it was a straight line basically right across all of those treatments. Okay? All right, so 2023, this is where I jumped on board. We jumped up to 21 states, 55 locations, same exact protocol as what they did in 2023. I will note that Maryland Soybean Board did fund my participation in this study in 2023. I was looking at these maps last night. You know what's kind of cool when you look between like 2021 or 2022 and 2023? You can see all the states that don't have agronomists maybe at their university, and you can see the ones that maybe recently hired agronomists at their university, because now all of a sudden those states popped up and they participated this year. So when I say we had exponential growth in this team from 22 to 23, yeah, it really shows on looking at these maps. All right. So here was the treatment list. Again, treatment number 1 in 2023 does not necessarily correspond. Maybe it does, but not necessarily between the 2 years. What is the same, though, is that treatment 10 was the untreated control. So some products got swapped in for 2023. Some products, whatever, got pulled out. So let's take a look at our Maryland results. No significant difference, all right? We see here at Poplar Hill that same trend, that same pattern as all of the other locations. These are Maryland results. These are national results. Everybody had graphs that looked just like this. No real significant difference compared to that untreated control. While we see a little bit more variability here when we're looking at our Y location, still no significant difference across those yields. I know these are different graphs than you guys are used to looking at, so I graphed them kind of the way I usually graph them. So we've got the 10 treatments across the bottom, our yield, and then the red bars represent our Poplar Hill, our down near Salisbury location, and the gray bars represent our Y location. Again, no significant difference. Yes, we saw difference in kind of mean yield between the 2 locations, but within each location, really no significant difference there. So nationally, locally, we're getting ready to kind of prepare our publication for this. We did not see an impact, neither positive or negative, of using these bioseed treatments, again, in our limited locations where we studied them. We are doing some further analysis of the 2023 national data, so we've got a really smart stats guy who is lumping all this data together and doing some additional analyses. But even from 2022 data, he didn't find that there was really a statistical chance that you're going to see a yield benefit. But interested to see what those results look like from 2023 too. All right, so if you saw me give my other talk, you've now sat through this talk, you're like, Nicole, I don't know, maybe there's something to it. I really want to believe that these products work somewhere. How can I decide if I want to use this product on my operation, if it's going to work for me? Well, I'm glad you asked. You can participate in our on-farm trials. All right, so I think I talked to you guys about it last year, but if not, funding for this portion of my research program is provided by the Maryland Grain Producers Utilization Board. We have an entire on-farm trials program now that is part of the research that I do. Because, you know, I didn't have enough to do before. Let's just add a whole nother program on, right? So I have a full-time technician, again, funded by Maryland Grain Producers Utilization Board, and he will come out to your operation, he will sit with you in your kitchen, and we will personalize these protocols to your specific operation. These protocols are just general guidelines, but we come out and we sit down with you and give you like personalized attention. Jean will come out and actually walk you through, physically help you with every step of this process. We want to make this as easy as possible for you guys to participate, but we want you guys to be able to come to us, test these products. We want to test these products too. I want to test these products beyond just the 5 research and education centers that we have, right? Even these other protocols, our wheat and our corn nitrogen rate, you know, we want to collect data beyond the amazing data that we are collecting at the research centers. But something like these biologicals is so, you know, individually tailored that I think everyone really has to test them on their farm to be able to make that decision for you if you want to use them or not. So we are looking for volunteers to do a nitrogen rate study on corn with us and to evaluate some of these biological products. You pick the product you want to evaluate. I have some suggestions, but if you've got a bucket or a jug of something sitting in your office and you want to try it out, call me. Please, please let me help you. Please let me help you evaluate that product, all right? If you are interested, but you still have some questions, you are in luck because Maryland Grain Producers Utilization Board is hosting a webinar on Tuesday where we are going to talk about how we do these on-farm trials. You will get to hear from 2 of our farmers that very willingly participated in 2023, and they're going to tell you how great of an experience it was. Or they're going to tell you not how great of an experience it was. I don't know what they're going to tell you. I'm kind of showing up too because I'm curious to hear what they're going to say, if they enjoyed it or not, all right? So if you have questions, if you think you might have an inkling of doing some of these trials, please join the webinar, and we will answer all of your questions, and you can hear from the farmers who participated. I'm done. Okay. Another point while y'all are thinking about questions. I forgot to put a slide in, but if you visit the University of Maryland Extension table, that's just on the other side of that window there in the sponsor room, I am part of a multi-state, I'm actually the lead of a multi-state project with Delaware and Penn State, and we are executing a virtual, it's an online experiment to understand a little bit better how farmers decide how they make in-season side dress nitrogen application decisions on corn, all right? It's a really cool simulation. You go through 10 growing seasons and you put out nitrogen, and our awesome behavioral economics team at University of Delaware can somehow figure out how we incentivize people to make decisions differently about side dressing corn. So it's very low risk. It's like 30 minutes of your time. You do it on the computer, and we pay you money just for participating. So if you are interested, there are handouts on the extension table that's just on the other side of that window, or come up and see me, and I'd be happy to answer questions. We would love your participation.
Hello, everybody. I just want to thank you for having us here, and if you guys don't know, I'm Sean Gunther with Dixieland Energy. We got a booth right outside here. We sell off-road diesel fuel, propane, lubricants. This is Rick. He's in charge of our lubricant department. anything you need, you can contact us. Right now we have a co-op we started last year for Queen Anne's County and Talbot County farmers. Really did well. We're doing 25 cents over rack for farmers, and goes all the way down to 9 cents, depending on how much you get. And if you actually are close to another farmer and we get a truckload, you actually get a discount for group drops. So definitely come and see me. And Rick, you have anything to say?
Yeah, just real quick. Because of the size and growth of Dixieland, we got a lot of our customers asked us about lubricants and everything. So about 4 years ago, we got involved with lubricants. We've got some of the best products in the world. Our prices are extremely competitive, very, very good prices. Please stop by and talk to us. In just the short 4 years we've done it, we're the fastest growing lubricant company in the area. We've now hired our 5th salesman. I mean, it's just, the growth is spectacular. We built a state-of-the-art bulk facility in Kirkwood and everything. So we're out here and we're growing and picking up a lot of customers, and they're very satisfied with our phenomenal service, immediate service. You order a product, 90% of the time it's the next day or the day after. So we're really looking forward to talking to you and explaining all the products we have. And please stop by the booth and say hi. Thank you.